Okay, good morning, everyone. So today we're going to present about the logical and statistical discussion. We're from Home Group 4 that consists of Jovita, Amaris, Aliara Marita Putri, Muhammad Reza Putra, Mikael Reno, Ben Osman, and Devin Raditya Sharif. So the one that will be presenting today is me, Aliara Marita Putri, and Ben Osman. So the first one, we're going to answer about the compulsory task. So we need to explain the census method of what our group has done and the reason and how big is the population in census. And we also have to mention the data variables of the census result done. Next, please. So the first one is census method. So the census method, we share the form in group class that has been done by Jofi. And why we choose to do this? Because it is lower at cost and it is also quick and easy. So the population is all ICBA class students, but the sampling is only 22 students in ICBA class because only 22 students taken the samples, yes. Next, please. Okay, so here are the result of the census that have been conducted. So the data variables is for the consensus one is that average sleeping time per day, average exercise amount per week, dietary consumption per day, height and weight. And for the census two is that height, weight, gender, and age. So the special task for a census two, because we are from home group 4, so we should answer the special task for census 2. This is about BMI and BMR, so I'm going to explain a little bit about BMI and BMR. So what is BMI? BMI is body mass index. It is a measurement of body weight based on height and weight. It applies to both men and women between ages 18 until 65 years old. And a high BMI may be an indicator that a person have a high body fatness. So if your BMI is less than 18, it falls within the underweight range. If your indicate that you're normal, if your BMI score is 25 under 30, it falls within the overweight range. And if your BMI higher than 30, it falls within the obesity range. And BMR, so what is BMR? BMR is the basal metabolic rate, and it is the number of calories you burn if you stay in bed all day. Because people use energy no matter what are they doing, including sleeping. And if you notice that every year it becomes harder to eat whatever you want and stay slim. So it is indicate that as you age, your BMR is decreases. Likewise, depriving yourself of food in hopes of losing weight is also decreases your BMR, a foil to your intention. However, a regular routine of cardiovascular exercise can increase your BMR, improving your health and fitness when your body's ability to burn energy gradually slows down. So BMR is uh, can be can be decreased if you have a regular routine of cardiovascular or other exercise. Next, please. Okay, so these are the BMI calculation. So how to calculate BMI is that divided by height in meters and divided by height in meters. So from that we know about the BMI BMI score is that Jovita have 21 BMI score, and it indicates that she may be a normal body fat, have normal body fatness. And then Raden Nazla is 18, is 19, which is under 20, so it may indicate that she is underweight. And Fatur have 29.30 BMI score, so it might indicate that he might be overweight. But from the BMI are that have been calculated, there are no obesity uh, indication from our class. Next, please. So the next one is BMR calculation. So BMR calculation is difference between men and women. So how to calculate it in men? BMR equals 10 times weight in kilograms plus 6.25 times height in centimeters minus 5 years plus 5. And in women, BMR equals 10 times weight in kilograms plus 6.25 times height in centimeters minus 5 times age years minus 60 161. So the difference is that men plus 5 in the calculation is plus 5 and woman is minus 161. So from the BMR we can know that from the Harris-Benedict formula, the BMR can determine the total daily calorie needs by a person from the BMR that have been calculated. So if you are sedentary, that little or no that conduct little or no exercise, it the how to calculate it is that BMR times 1.2, and if you are lightly exercise that have like sports 1 until 3 days a week, it how to calculate it is that BMR times 1.375. And if you're moderately active, that means if you have sports 3 until 5 days a week, how to calculate it is that BMR times 1.55. And if you're active or have hard exercise like sports 6 until 7 days a week, you have to times the BMR times 1.72. And if you're extra active or very hard active, like you have a sports and physical job or 2 times training, the how to calculate it is that BMR times 1.9. So for example, I'm going to take an example from Nazla because she has zero exercise. So she is included in the sedentary or little or no exercise part. So we have to calculate it by multiply 1243.8 times 1.2, and it equals 1492.56, and it is the total calories needed by her to maintain a normal calories needed. Next.
So the next one for D, the instruction is make a frequency distribution table or group frequency distribution for the BMI and BMR data. So the first one, this is the frequency distribution table of BMI. So the variables there are for variables height, weight, age, and gender. So to read the table is like for 150 centimeters there are two persons. The weight is 43 and 50. The age is 20 and 21, and the BMI is 19.1 and 22.2. So the total for 150 centimeter is 41.3, and for the 159 centimeters there is only 1%. So it's 3 to the total 21.35. For 160 there is also only 1%, so that it's 3 to the total 20.70. For 163 there is also 164 there is only 165 there's only 1 also. And moving on to 167 centimeters, there are 2 data. The first one is the weight is 80, and the second one is 67. So the BMI is 20.07 and 28.34, and the total is 75.97. So it goes on until the last one is 186. And this is the graph. Moving on to the BMR, it is also the same. There's height, weight, gender, and the total. And to read it is also the same. So for the height 1.5 meter, there is 2 data, and until 1.69 centimeters there's only 1 data, and in 1.69 meter there's 2 data again, which is 67 and 75. Their BMR is 1692.9 and 3591.4. So the total for 1.69 meter is 5284.3. So this continues until the last one is 1.86 meter, 1.86 meter. And this is the graph. Moving on to the next one, the instruction is make the graphic that fit all of the BMI and BMR data. So this is the graph. The sample is in the right. There are 22 samples, including the sum and average. So this is the BMI and BMR graph of the 22 samples. And for F, the instruction is make a conclusion sentence that represent the information of the BMI and BMR graphic. Because only one sentence, so the conclusion for us is BMI and BMR graph is the bigger their BMI, the bigger their BMR too. The example is like myself, my BMI is 32.1 and Ryan's BMI is 28.3. And for my BMR is 2098.3 and Ryan's is 1866. So it can be seen that because my BMI is bigger, my BMR is also bigger than Ryan's. And moving on to G, the instruction is make two BMR graphics for data of the biggest and the smallest BMR value from the census as the function from the age from the age to the increase of age every 10 years up to 80 years old. So the first one, we identify the smallest and largest BMR. So the smallest BMR is Nazla with 1,243.8, and the largest one is Ben 2,098.3. And because the instruction is every 10 years, so starting with the age 20, then every 10 years, so 20, 30, 40, 50, 60, 70, and 80. And for Ben, because he's starting at 19, so every 10 years is 29, 39, 49, 59, 69, and 79. So these are the data for Nazla age 20, 1,243.8, age 30, 1,196.8, age 40, 1,149.8, age 50, 1,102.8, age 60, 1,055.8, age 70, 1,008.8, and age 80, 961.8. While for Ben's BMR, age 19, 2098.3, H29 2030.3, H39 1962.3, H49 1894.3, H59 1826.3, H69 1758.3, and H79 1690.3. So after we compile all of the data, this is the BMR. So the first one is Benz BMR, and the second one is Nasdaq's BMR. And for the last one, for H, the instruction is to describe in sentence to explain the changes in BMR value in every increase of 10 years. So the for the changes, the basal metabolic rate decreases almost linearly with age. This is also mentioned by Alia before. As we get older, our BMR starts to decrease. And this is shown that the decrease in muscle mass relative to total body may be wholly responsible for the age-related diseases in basal metabolic rate. Energy consumption by physical activity also decreases with atrophic changes of skeletal muscle. And for the second instruction, then describe in sentence to explain the impact body height changes and body weight in the change of BMR graphic in task J. So these are the impact of body weight and weight of BMR graph. The reason height and weight are factors is because the more body surface you have, the more energy is required to keep functioning. A tall person will have higher BMR than a shorter person, even though they may weigh almost the same. And the basal metabolic rate averages 5 to 10% lower in women than in men. So that's all for our presentation. Thank you guys for watching.